So what are the sources of a digital elevation model? We can make digital model in different ways. We can get DEM models in different ways. That is, just assume that you have a rectangular grid, and this rectangular grid, every cell has a height value, has an elevation value. How to get this elevation value? So mainly the sources will give us the height value. So whenever we get multiple height value, we can do the interpolation, and then we can find, or we can conceive and represent a curved surface, a geometrical surface which is actually the mimicking the Earth surface. We also have a TIN, triangular irregular network, in which every triangle is representing the equal height. This is one more representation of DEM. So from all where we can get the DEM, the first one is quite cumbersome, but it is the most popular, widely used today also. That is the ground surveys. That is, if you are really interested in some place, the area will be less you can cover, but the points will be quite accurate. Ground surveys. The second way to get the height or elevation or DEM is the manual photogrammetric stereo method. Photogrammetry is calculation from the photo, measurement from the photo. So whenever we take this aerial photography, the area which is say common, now same point on two different images, we can find out height of difference using the parallax method. Then third one is the automatic topographic extraction from images. There are methods, there are technologies, there are algorithms where we can extract from satellite images and aerial photograph directly the automatic topographic extraction. This we can do. There is one more way. This is to digitize from existing topographic contour map. Previously, people used to keep it on the board and do it using the actual digital device. But now we have the Esri, ArcGIS, Quantum GIS, Map Info, and GVSig. There are so many software you can easily you can do it using computer. So we have good software to do it. Then we have the laser scanning. This is coming from LIDAR. LIDAR is light detection and ranging. So this laser scanning is done using a fly, and that flight will have a laser, and that laser, the point it goes and comes, the different points where it reflects from the ground, we get a proper shape, we get a height, and then we can make a shape. Okay, so this is the model we could make, mathematical or geographical model using these points. Then the final one is this is very important, this is a radar interferometry. So we have, for example, SRTM data, that is shuttle radar topography mission. Here the different phases of different waves, the difference of the phase will give you the height between 2 points, and this height can be used to make a DEM.